Hi everybody, Mike Nelson here on the Denver Channel Facebook page, and it's Weather Wednesday. We're a little late in starting as we had to wait for the governor to finish his press conference, but now we're going to get rolling on this Earth Day, the 50th anniversary of Earth Day. And as appropriate, we're going to talk about climate change in our Weather Wednesday lesson. It's certainly a topic that is very, very important, and aside from the pandemic, has been one of the top subjects to talk about worldwide. So let's get started at it right away. First of all, I'm just going to teach for a little while here, and then we can do some question and answer time a little bit later. Let me get through a fair amount of this, and if you have some questions, you can write them up on the Facebook page, and we'll try to get to as many of them as we can. My contacts, Mike Nelson at kmgh.com. That really should be now the denverchannel.com. I apologize on that one. Facebook, Mike Nelson 7 News, and Twitter is Mike Nelson 247. So one of the questions I'm oftentimes asked is it really the responsibility of a television weather forecaster to talk about climate change and global warming during our weather reports? And our main job is to be the nice, friendly person that tells you what the high and the low is going to be for the day and what the weekend forecast is going to be. And given that there are Americans that are skeptical about what's really happening in terms of our changing climate, we need to make sure we get the proper science out to the public. One of the strengths that we have is that we take complex subjects, the weather, and in about 2 to 3 minutes can explain what's going to happen, why it's going to happen, perhaps educate you about some of the reasons behind why the weather is going to be doing what it's doing. And so that's where a weather forecaster on television has a unique gift, in that we talk to the general public every day, and we do it in simple, understandable terms. We just have to be careful not to mix too much physical science with political science. And is it our responsibility to discuss climate change in our weather reports? This cartoon says our extended forecast includes global warming and the catastrophic end of the human race. But the weekend, it's looking like sunny skies, mild temperatures, and a general apathy toward environmental concerns. Back to you, Jim. And unfortunately, that is pretty close to the truth. And we get this one, let me go back one. Certainly in the wintertime, I'll get this very often where people will say, hey, you know, I've got 36 inches of global warming in my driveway. And it's important to know that weather and climate are two very, very different things. And certainly we get these kind of responses. We had it last year. We had that big cold wave in the upper Midwest, and there were tweets out there in the world saying, well, where's the global warming? Well, that's weather. That is not climate and not climate change. And as weather forecasters on TV, we are the station scientists. We're asked all the time to talk about different things that aren't meteorology, but they are science. There might be an asteroid or a meteor shower, so the news director comes to us and says, hey, can you talk about the meteor shower tonight? Well, that's not my background in astronomy, but I've learned enough to be able to talk about it. Or we have an earthquake. And can you come on and show us more about why the earthquake happened, where it happened? Again, that's not my strong suit, but I've learned enough to talk about it. Tsunamis, same story after the earthquake, and volcanoes. We're asked all the time as the station scientists to comment and offer some background on why these things are occurring and provide some insight to our audience. And of course, because we are as close to a scientist, they're not going to generally run into somebody from NCAR walking down the street that they can ask, hey, tell me about this global warming. I think we must help educate our viewers. And this is a shot from a few years ago. Global warming is a hoax because it's cold where I live today. Jon Stewart on The Daily Show back a little while ago. But it's a serious problem, folks. A year ago at Earth Day, we had our big event that was done down at the Denver Museum of Nature and Science. We're having another one tonight, but it's virtual. I'll talk about that a little bit later. And this is one of my favorite slides from that in the IMAX theater last year, and that is, we need to start worrying about what kind of world we're going to leave for Keith Richards. It seems like no matter what, Keith Richards will probably survive it. Okay, well, a little background. Global warming and climate change wasn't really on the radar, if you will, when I first got on the air back in the 1970s. Here's my big haircut, by the way. It's still fairly big, but it's a lot more gray now. It's not just for rock bands back in the day. And here are some pictures of me doing the weather back in the 1980s with some of our very early computer systems. Things have certainly changed a lot, including the hairstyles and the fashions. But now what we've seen in the last 40 years is a revolution in the computer systems and the way that we can present weather to our audience. Think about this, that I'm doing this right now from my basement because, of course, we're in the pandemic right now, and we have the technology that I can talk to you over all of this internet capability and present weather and severe weather information and climate information. This did not exist certainly even 10 years ago, let alone 4 decades ago. As many of you know, I still try and visit the schools as often as possible when we get past the COVID-19 crisis that we have. And I love talking to school kids. This is a picture of me back in the 1970s with my 35 millimeter slideshow that I used to take out to the schools. And of course, doing the tornado dance is one of my trademarks. Over the last 40 years, I've spoken to about 1 million children in the grade schools, and I take a lot of pride in that, but a lot of energy from it too. When I talk to the kids in school, tornadoes and severe storms and hail and hurricanes, blizzards, those are still the real draw. You're not going to spend an hour talking to kids about radiative transfer theory with global warming, but you can throw in some basics about climate. And I urge my other broadcasters around the country, don't be shy about this when you're talking to the school kids or the Rotary Club or anything like that. You've got to talk about climate change along with the hows and whys of our daily weather. It's just that important. And what I usually tell the kids, and I'll explain a little bit further here, is that, the carbon dioxide is in the air right now. We breathe it in and out. It's not poisonous or anything like that, but what it does is acts like a blanket around the planet, trapping heat from escaping in outer space. That trapped heat gradually warms up the planet. And when we burn gasoline in a car or coal in a power plant, we're adding more carbon dioxide in the atmosphere, trapping more heat. Pretty much that simple. But I also leave them with a message of hope. Our smartphones that we can't live without today have much, much more power than a supercomputer had 25 years ago. We carry them in our pockets. We don't know what amazing inventions these kids are going to come up with someday when they grow up. And this is one of my favorite stories out at Lockheed Martin a couple of years ago. They were building the new GOES weather satellite, and I was out doing a stand-up in front of all these technicians in the clean room out there. And when I got done with my stand-up, they all came right behind me and they said, "Hey, Mr. Nelson, can we take a selfie with you?" And I said, "Yeah, sure, why?" And they said, "Oh, you totally came to our grade schools when we were little kids." And I'm thinking, yes, that's what it's all about. This is rocket scientists now, and perhaps my visit to their schools back in the 1990s is part of the reason they're doing what they're doing now. And who knows what these students will come up with in the years ahead. That's where I take a great deal of excitement. Matter of fact, I just got this one earlier this week. This is Evelyn. And Evelyn had a report due about weather that I helped her on with some of the information. She's got my picture right there in a tornado. And her conclusion in her report was, now that I know what weather can do, I still find weather interesting. I might decide to be a meteorologist when I grow up because I'm really interested in weather. You go, Evelyn, because who knows, Evelyn might be a scientist that solves some of the problems that we face right now. All right, so let's talk a little bit about climate change and what things do we know for sure. Okay, we know, people tell me, these are the kind of things I get asked when I go out and speak to a service club or something, the questions afterward. People say, well, Mike, climate's changed all the time. Yes, we know climate has changed because we know we've had ice ages and mass extinctions and continental drift. Climate has always changed, and ladies and gentlemen, that is exactly why we know what is happening right now. We know the causes of climate change, shifting in and out of ice ages. And they are really just 3 things, okay? Changes in the orbit that we go around the sun. It's not in a perfect circle, it's in an ellipse, and that will shift a little bit over the course of about 100,000 years. The axis of the Earth also wobbles a little bit, and the precession, it'll move around a little bit like this as well. So these 3 things, the eccentricity, the axis tilt, and the precession that the Earth does, was all figured out mathematically by hand by a Serbian mathematician named Milankovic. If you want to look it up, you can read all about it. He went on for months and months and months deriving all this, and this is what shifts us gradually in and out of ice ages. We also know the output of the sun, although it's pretty constant, it's not always constant. We know the solar cycles, and that will change. Sun gets a little hotter, a little bit cooler at different times, and the atmospheric chemistry. And of those three things that we know drive us in and out of climatological changes, there's only one. There's only one that is changing very rapidly, and that is the chemistry of the atmosphere. This is in and out of ice ages, because when things freeze up, some of that carbon is trapped, and when it begins to warm up, some of the permafrost, the oceans, release that carbon dioxide back into the atmosphere. That's why we know it goes up and down. But look at this. Today, globally, the average is about 414 parts per million, and that is the highest that we've seen in at least 800,000 years, long before mankind was on this planet. And we know it's not because of changes due to volcanoes or other natural instances, because we can identify the chemical isotope of that carbon. It's plant-based. It comes from old carbon sources, such as when we burn fossil fuels. You burn a chunk of coal, you release that fossil carbon into the atmosphere. So we know by the concentrations that what is in there because of us digging up fossil fuel and lighting it on fire. People say, well, yeah, but Mike, we only have 150 years of records. How can you possibly know all this with the temperatures? Well, climate scientists are pretty clever, folks. And how do you think they know where to drill an oil well? Do you think they just go out there and say, well, that looks like a good spot over there. I'll stick an oil well in the ground there. No, we're really, really good at recreating the past by proxy, by looking at the shape of the landforms, looking at the rocks to figure out where the synclines and the anticlines that might contain oil or natural gas exist. We can recreate the past. We can do the same thing with figuring out past climate by using ice cores and tree rings and coral and sediment cores. Ice traps ancient air, tens of thousands, hundreds of thousands of years old, and in those little bubbles we can identify the concentrations of carbon dioxide. Coral can indicate temperature. I know that's a big problem right now because we're having tremendous coral die-offs as the oceans get warmer and fizzier, because they, of course, absorb some of that carbon dioxide. And sediment cores can reveal the ancient ocean chemistry. We're really, really good at recreating the past, even though we might only have thermometers around for a couple of centuries. And folks, this is not just since Al Gore or anything like this. Climate science is much older than that, long before Al Gore's grandparents were born, okay? So back in 1825, Joseph Fourier, you might know the Fourier series from mathematics, realized that the Earth was way too far away from the sun to be as warm as it is. And his theory was that the atmosphere traps that heat coming from the sun from escaping back into space, making the planet warmer. Time of the Civil War, John Tyndall, an Irish chemist, identified carbon dioxide as the gas that absorbs this long wave energy, among methane and some other gases. And in 1895, Svante Arrhenius, a Swede, calculated that doubling of global CO2 would warm the Earth by several degrees, with the warmest happening in the high latitudes, north and south. And let's not forget the women. In the 19th century, it was not common for women to be accepted as scientists, but we had a really brilliant lady named Eunice Foote, and she was an American scientist, and she took jars and filled them with different gases, oxygen, nitrogen, CO2, and then measured the temperature of those jars, and noticed that when the sunlight hit it, the jar with the CO2 warmed up the most. And there's even a paper here affecting the heat in the sun's rays by Mrs. Eunice Foote. If you do a little Google search, you can find out more about Eunice Foote. And folks, this is not political. Okay, this is not politics. This is physics. Okay? Without the greenhouse effect, the planet Earth would be about 60 degrees colder than it is, and it would just be a frozen ice ball. So greenhouse gases are great things, but unfortunately, we have now too much of a good thing. Each doubling of carbon dioxide increases the energy retention around the entire planet by 3.7 watts per square meter. That's about the same as an old-fashioned Christmas tree bulb or a night light for a child over the entire surface of the Earth. But take that entire area, it's a huge amount of energy with each doubling of CO2. We can measure it in a lab. These measurements have been done thousands of times, recreated thousands of times. And when you cause that, that's something called forcing. You trap the heat, that's forcing something to happen, a new balance in the temperature of the planet. So the forcing from that doubling of carbon dioxide is about 5 degrees Fahrenheit of warming over the entire Earth. We're seeing it in the melting of the ice caps and the glaciers, and that could cause sea level to rise tremendously, 5 to 10 feet. Some research shows even higher than that. This is thermodynamics, folks. Add heat, get warmer. Get warmer, melt ice. Melt ice, sea levels rise. Okay, so over the course of time, I have had plenty of different things asked of me about climate change. And here are what I call my 7 deadly sins of climate change denial. The sun is responsible. It's all natural. The Earth has not warmed since 1998. Carbon dioxide is just a trace gas. Hey, back in the 70s, they said it was cooling. It's snowing in fill in the blank. Therefore, it can't be getting warmer. Some place that's normally warm has had snow, so it can't be getting warmer. The thermometers are wrong, or we cannot trust the media and the scientists. Okay, let me step through some of these. Okay, first of all, the solar argument fails the test, okay? This heating up that we're having on the planet is not because the sun is suddenly getting hotter. If anything, we are seeing that the cycles don't add up. We see the temperature cycles going up. We see the carbon dioxide going up. Solar cycles vary, but they are not going up. And if anything, we should be in a gradual cooling pattern right now. We should be on this curve going back from the last ice age, warmer temperatures. We should be cycling down slowly toward the next ice age, but we're actually seeing the temperatures spike. People call it that hockey stick. Well, that's because it looks like that. That's what the temperatures are doing. And if you look at the observations, warmer temperatures, you add in the green line, the anthropogenic or man-caused plus natural going up. And if you look at just natural in climate models, that warming is not occurring. So it's not because of the sun. It's not because it's just natural without the impact of mankind. And we've heard these, boy, that argument used to be out there a lot back in the early 2000s. Hey, it's actually cooling since 1998. Well, 1998 we had a massive El Nino, which is a big pool of warm water in the Pacific Ocean. It put a lot of that heat back into the atmosphere, so that was a very warm year. Went into some years we didn't have El Ninos or even had La Ninas, which is kind of cooler air, water rather at the surface, and so the global temperatures dropped while the ocean temperatures continued to get warmer. So it does bounce around a little bit, but you can see that in the absence of a strong El Nino, we are still getting that warming happen. So those ENSO cycles, which is the El Nino Southern Oscillation cycles, are the main reason that the warming occurs in steps and not just a gradual slope. But the warming does continue. And you don't hear much about that 1998 argument anymore because it's been so patently proven false with all of the record warm years that we've had in the last 5 to 10 years. Now this one I get a lot. Carbon dioxide is just a trace gas. How could that possibly have such a big effect? I mean, we're talking parts per million. Well, think of each molecule of CO2 like a feather in a down comforter, and it's trapping heat from escaping out. If you have a thicker down comforter, at night you'd stay warmer underneath that as it traps your heat. The same amount of carbon monoxide in our air at 410 to 415 parts per million would render us unconscious and close to death. Now, carbon monoxide is poisonous. Carbon dioxide is not poisonous, but its feature is that it traps heat. And the way that it does that is you've got a carbon molecule and 2 oxygen molecules. And when the Earth's heat travels through that, they do this little dance. And that little dance is what sends the energy back down toward the ground. If you look at CH4, methane, it's got a whole lot of stuff moving on when the Earth's heat goes through it, and that dance is what pushes the heat back down or traps it close to the Earth. O2 and N2 just go like, wah, wah, but CO2 and CH4 are like, wow! And with that, we get the Earth's heat being trapped. The key thing is small amounts matter. How big do you think that COVID-19 virus is? Tiny, but it certainly has had a major impact. So size does not always make the difference. Small things can make a big difference. Okay, I hear this one a lot too. Hey, Back in the 70s, you guys said it was all going to be a new ice age, and there were magazine articles about the coming of the new ice age. And yes, there were. I have a couple of books in my library that talk about the cooling or the great hunger, things like that. Well, I was there, folks. This is Cindy and me back in the 70s, and we had the same hairstyle then. Well, the fact of the matter is what happened in the 1970s is we did have a couple of years of really cold winters across North America. And there were some articles that were posted saying, could this be a sign of a trend that we'd actually be heading into a new ice age? Well, even at that time, by far the majority of research papers being published said, well, it's having an impact. What that was is when we burn coal or oil, especially coming out of World War II and really industrializing in the 1950s and 60s, put a lot of dirt in the atmosphere. Aerosols, tiny little particles. Those tiny little particles blocked out the sunlight, and it was like a volcano would be, it causing a cooling of the atmosphere. And the thought was that's going to cause the ice caps to continue to expand. We'd get more reflectivity off of the ice, continue to cool the temperatures. Ice would continue to expand. It would be a cycle that would continue to push us into a new ice age. But even then, you can see that the vast majority of articles talked about warming, not cooling, back in the 1970s. And this is because even then we knew the effect of the increase in carbon dioxide would ultimately overtake this aerosol or dirty window effect. Okay. It's snowing in the desert. It's snowing in Las Vegas. It's snowing in Jerusalem, whatever it might be. Therefore, it can't be getting hotter. Well, remember this. Climate is what you expect, and weather is what you get. And it's a little small here, so let me read this. Climate is a long-term average. Weather is chaotic, and it changes frequently. You would expect Miami to be warmer than Denver in February because that's the climate of South Florida compared to Colorado. The local weather on a given day, though, could make it 70 degrees on a Chinook wind day in Denver in January, and maybe a cold front moved through down in Florida. It was just in the 50s and raining. That doesn't mean the climate of Miami suddenly changed. It meant you got a bad week that you chose to go to Miami. And in that respect, it is easier to predict climate than it is to predict weather. Basic thermodynamics. If you add heat to something, it gets warmer. It's why day is warmer than night, and it's why summer is warmer than winter. When people say, well, you know, I'm not a scientist, I'm a politician, I don't know about this climate change. Well, you did go to grade school, and you did learn that if you put a pot of water on the stove and turn on the gas, that water's going to get hotter. So you did learn that when you add heat, it gets warmer. You don't have to be a rocket scientist or a climate scientist to understand that. Another analogy that I like to use is that weather is one play in a football game. Climate is the entire history of the National Football League. Think about that. Okay, so over the course of time, the league changes and the rules will change a little bit, but on any given Sunday, one team can win. But when you look at long term, that's much more like climate versus weather. If it's snowing in Las Vegas, well, it is wintertime, and we expect more unusual weather events to occur as the climate system gets more energy. Global warming creates a steroid effect. And I put down here McGuire and Sosa from way, way back in the day. But this steroid effect will make droughts more extreme or add moisture, increasing rain intensity in a flood event. It juices things up. And that's one of the things, a lot of times we'll call it global weirding because things are just getting weirder out there. A couple more things that I get as pushback. The weather stations aren't accurate. Look, I can go on this website and it shows me a picture of a thermometer that's sitting over a parking lot. Yeah, there are some that are compromised, certainly as urban development, the heat island builds up. But the coral and the ice tell the true story. They don't care whether the station is on a parking lot. The ice is melting. The coral is dying because the world is getting hotter. Couple more here. Hey, Mike, I watch you. You don't get every forecast right. You can't even predict tomorrow's weather, let alone 100 years from now. The computer models are not good enough to really tell us what will happen, or those climate scientists are just trying to achieve worldwide domination like Dr. Evil. Right, okay. Okay, well, I agree. I've got a t-shirt that I really like that says, well, it seemed like a good forecast at the time. And remember, long-term climate is easier to predict than short-term weather. Computers are getting a whole lot better, folks. Up in Cheyenne, the supercomputer center for NCAR, 70 million times faster than the original Cray 1 supercomputer that is still in the basement at NCAR. You can actually sit down here, have a cup of coffee on the bench or on the cooling towers there. 70 million times. And this isn't even the fastest supercomputer that's out there, and they're rapidly getting better and better. So the models have become very powerful at recreating past climate and helping us to predict future climate. And there's a picture of the typical hangouts for those obscenely wealthy climate change scientists that have made so much money trying to fool the entire world. The yachts are parked right here, beautiful flowers, and there they are, those climate scientists scheming about how they're going to take over the world with this false narrative about how the climate is getting warmer. Well, actually, folks, this is the parking lot up at NCAR up in Boulder. And you do not see very many Jaguars or Mercedes there. You see a lot of 10-year-old Camrys and things like that in the parking lot up at NCAR. If those scientists are making a whole lot of money, they're doing a terrible job of investing it, because you certainly don't see it based upon the vehicles parked in the parking lot. And I love this particular bumper sticker there. It says, "Mother Earth bats last, and she's warming up." And certainly we have sort of seen that in what's going on with COVID-19. Mother Earth certainly does hold a great deal of power. Now, folks, a warming world doesn't mean that we're not going to get cold and snow. Remember, those are seasons we have and storms, weather versus climate. So we'll still get our snowstorms. This is Denver's biggest one ever, December 1913. But our last really big one, March of 2003. I like the fact we still have the cable buses running at the same time. But here's what a warming world does mean. It does mean that we can expect droughts, wildfires, and floods to become more frequent and more extreme. This is 3 straight years along the Front Range. The awful fires back in 2012, the terrible flooding in September of 2013, and then the drought that followed in 2014. We'll see more of this stuff as the climate gets more energy. So that's some of the bad news, etc. What are we going to do here? What are we going to do? So powering forward. We cannot do very much in the short term to stall or reverse the warming, but we can help to plan to mitigate the impacts. People have said, what's the effect right now, because we've had this economic slowdown and there's so fewer cars on the road, airplanes in the sky? Well, we're seeing the increase in carbon dioxide has slowed a little bit in the last 2 months because we're not burning as much fossil fuel. But you have to remember that carbon dioxide's lifespan in the atmosphere is centuries. So we've been throwing another brick on the pile here since the beginning of the Industrial Revolution, adding more and more carbon dioxide into the atmosphere. And with that, that warming is baked in now for quite some time. So with that being the case, even if we are to be able to, in the real short term, greatly diminish the amount of fossil fuel that we're burning and the amount of carbon dioxide that we're adding, which right now is about 10 billion parts per day in the atmosphere, we're going to have to mitigate the impacts of this warmer world. Increase our water storage, promote water conservation, new road construction techniques. Do you rebuild the Big Thompson Highway in Big Thompson Canyon the same way after a flash flood, knowing that it's more likely there may be another one in the next 2 decades? Maybe you come up with better techniques so only part of the road washes away. Modernize your fire and forest policies, improve public warnings for storms, change zoning in threat areas, new agricultural techniques, and smart and effective regulations. These are all things that we can do right now to help mitigate the problems faced by a warming world. And what to do? How do we get away from lighting carbon on fire? Well, we have to electrify everything, okay? Transportation, heating, light, industrial, got to electrify everything. And it's going to take a lot of juice to do it. Just for instance, when you hear about terawatts and gigawatts and megawatts, well, 1 gigawatt is the equivalent of a nuclear reactor. It's a good way to think about it. In California, they have laws that have mandated 100% renewable energy by 2045. Colorado is doing a very good job on this as well. And so as we electrify everything, it's going to take a lot of juice to do this. The same amount of energy for an electric vehicle is needed for an average size house. For an electric bus, like we run on the Pearl Street Mall in Denver, that's the same amount of energy as take for 400 houses. For an electric truck, that's the same amount of energy it would take for 700 houses. We're talking a lot of electrons. And you can see as we get to these mandates, California and in Colorado, the energy needs are going to grow up dramatically. We're only just kind of scratching the surface now, maybe about a third of the way there. And this is the best we're doing in California and in Colorado. We've got a tremendous amount of growth we need in renewable energy for buildings, for cars and trucks, and in battery storage. Fortunately, we have a lot of resources too. These are some of the massive solar fields that are going in, especially out in the Mojave Desert area, northern LA County, Kern County out in California, some of the big wind farms there, the battery storage. We're doing a lot of this in Colorado as well, but it's amazing what we're seeing out there. And with the resources are right here. This is a map from NREL, National Renewable Energy Lab, of all of the resources that we have for solar. Very good in Colorado, excellent in New Mexico, southern Utah, Arizona, California, Nevada. But the nice thing is, this is the area that's prime for wind power. So it's not nearly as good for solar in the Midwest, but it's way better for wind. And in 1931, Thomas Edison said, I'd put my money on the sun and solar energy. What a source of power. I hope we don't have to wait until oil and coal run out before we tackle that. Now, one of the things people have been asking me is, since we've had this slowdown due to the coronavirus, what's it done as far as environmentally? Well, great things. In India, they can actually see the Himalaya mountains for the first time in decades. The air is way cleaner in China, although that's starting to work back again as their economy comes back online. Los Angeles had some of the cleanest air they've had in decades as well recently. So you know that if we stop burning fossil fuel and all that transportation, the air gets way, way better. And these countries already realized that their citizens cannot breathe the air. And they needed to work more toward renewable energy sources because they've got to reduce their coal consumption for health reasons, quality of life reasons. And now, after people have seen, wow, the sky is blue and I can see stars again at night, I think that's going to further the incentive for people to say, I want to clean up this air quality, and we need to use more renewable resources, wind and solar especially. And in the third world, people oftentimes say, well, yeah, but you know, the third world has to be able to build their economy like we did. That would be the equivalent of saying, oh no, you can't have cell phones. You've got to have a rotary phone like this, like we had back in the early part of the 20th century. You've got to use the same model we do. They're not going to use that same model to modernize in the third world. And so right now in the third world, they spend about $38 billion a year on kerosene to burn in lamps so they can read at night. Lung problems, we have heart problems, asthma, all of those issues because we're burning a dirty fuel. You bring in a solar panel and an LED light into a village in the third world, you transform that village. You put a wind turbine up, and they can suddenly have refrigeration for vaccines and clean water. They're not going to use the same model that we used 150 years ago to modernize. And the change can be dramatic and fast. This is New York City, Easter Sunday in 1900 8th Avenue. There is one car, I think, right there. Otherwise, it's all horse and buggy. This is the same street, 13 years later, Easter Sunday, and there's one horse and buggy right over here. All the rest are cars. Change can be dramatic and fast, from the horse to the auto in 13 years. From gasoline, coal, to electrifying everything, it's going to happen fast. So folks, the carbon age is ending. Fossil fuels are losing market value. You saw just the other day that there was about, minus $38 a barrel on futures for oil. Coal companies are going out of business because the the volume of their product, the need of it, is going down so dramatically. So switch over to renewables, and at the present time, natural gas, which is a big bridge fuel that is taking down the coal industry quite a bit in terms of its need. These are dirty fuels. They will be replaced in the future. You have to think ahead toward the future, how this is all going to happen, and we'll transition into the age of silicon. New energy revolution. I talked about how we've gone from the crayons I used to draw with back in the 1970s to the fabulous computers we have right now in terms of television weather. Look at removable storage here. In 1956, 5 megabytes was $120,000. You had to load it on a crane to put it in an airplane. And now you look at what we have with just our little chips that hold gigabytes of information. They cost almost nothing. Air quality, Los Angeles, 1968. Clean Air Act, cleaning up considerably, and we talked about it's gotten much, much better now, as a matter of fact. But then you've got computers. Back then, giant mainframe fills up a whole building. That's a computer now. Energy then, energy now. We can't advance from this. We don't have the knowledge and the innovation as a species to figure this out. We can change the way we power our world, conserve our environment, and keep our economy growing at the same time. We like to walk the talk at Denver 7. We have solar panels on the roof of our building. Our radar site, solar panels. Put solar panels on the roof of our house, and we power the weather center with the sun and the wind. I drive a Chevy Volt, which I've had for a number of years. I'll upgrade to something soon, I think, but I get 100 miles to the gallon. It's a great car. And these, as we know in Colorado, these renewable energy jobs, of which there are way more jobs in renewable energy than there are in the service industry, in the food industry, the restaurant industry. It's crazy. They're good jobs. These wind turbines are huge. You see those blades going down the road on a truck. You can't build them in China and ship them here. Everything's too big. These are Colorado jobs, and they're very good, high-paying jobs. And the solar industry is exploding as well. So there are many more jobs in renewable energy than in coal, and you cannot import those turbines. They're too big. Now, people say, what about the blades? You gotta, they wear out and you gotta bury them somewhere. Yes, I mean, until we get nuclear fusion, there's probably no free lunch on energy. But burying what's left of a used fiberglass blade in a landfill is pretty stable. Burying what's left of nuclear fuel rods, that will stay hot for 20,000 years. Well, we can't do this. It's going to be just too big, Mike. It's too expensive. It's too late, whatever it might be. We've done this before, folks. Great and expensive projects have been completed in our past. They did not bankrupt our country, and they made our lives better, and we can do it again in the future. The Transcontinental Railroad. Water treatment and plumbing. 100 years ago, we tore out all the walls in the tenements in big cities and put in plumbing. And so you have sewers and fresh water. Aren't you glad that that happened? Yes. A rural electrification project, the Manhattan Project, the interstate highway system, NASA and Apollo, fiber optics, the internet, high-speed computing. All of these things were expense, but they were investments, not costs, and they made our world a better place. Talked about this earlier. These things didn't exist 25 years ago. More powerful than the world's first supercomputer. This is from the old movie Back to the Future. Maybe we get Mr. Fusion, drop the banana peel in the thing, and you get fusion power. They always joke that fusion power is just 25 years away, and it's always just 25 years away, but someday we'll figure out how to harness energy from the stars in a fusion reactor. But we already have a fusion reactor. We have a great big fusion reactor 90 million miles away, and it shines on us every day, bringing tremendous amounts of energy that we can use in wind and solar. So in a way, we already have fusion. It's very safe in the distance it is, and it's going to last for a long, long time. Okay, I want to finish up here with a few quotes on this Earth Day. First of all, I'll start with the cartoon. Energy independence, preserve rainforests, sustainability, green jobs, livable cities, renewables, clean water, healthy children, etc., etc. And this guy says, well, what if it's all a big hoax and we create a better world for nothing? Okay. From Albert Einstein, the significant problems we face cannot be solved at the same level of thinking with which we created them. Gaylord Nelson, founder of Earth Day 50 years ago. No relation, but from Wisconsin, my hometown as well, or my home state as well. When it is asked how much it will cost to protect the environment, one more question should be asked. What will it cost our civilization if we do not? And from John F. Kennedy, today our concern must be with the future, for the world is changing, the old era is ending, the old ways will not do. When I was a kid growing up during the 1960s, I was absolutely infatuated with the space program. The race to the moon just captured my imagination, and the scientists were rock stars. We'd have a problem with the rockets, we'd fix it. We got to the moon. And scientists are unfairly denigrated right now as having some ulterior motive to their research. They are scientists. They're presenting good science, whether it be on the coronavirus or whether it be on climate change. We need to continue to inspire children to engage in math and science, remembering that the problems are real, but solutions can be found. And whenever I talk to a group of school kids, I stop and I say to the teachers, let's thank these world changers for the amazing things they are going to create in the next 30 years. And we give the entire gym full of kids a round of applause because they will change this world. One more quote from John F. Kennedy. And this was in a speech that if you look it up, it's called the New Frontiers speech. It was the speech he gave to the Democratic Convention when he accepted the nomination for president. He said, "We stand today on the edge of a new frontier, a frontier of unknown opportunities and perils. It would be easier to shrink back from that new frontier, but the times demand new invention, innovation, imagination, and decision. Our problems are man-made, therefore they can be solved by man. No problem of human destiny is beyond human beings." Made it to the moon before the end of the 1960s. And folks, our next moonshot is to electrify everything with non-carbon fuels. Real quick, when Yuri Gagarin, the first human being in space, got to the top of the atmosphere in his Soyuz spacecraft, he looked out of the tiny porthole in his spacecraft and he was terrified. Not that there was something wrong with his ship, but because he'd been taught since he was a child that he lived at the bottom of a great ocean of air. And as he looked out at the cold blackness of space, he realized how fragile and isolated our planet looked, and it terrified him. As far as we know in the universe, this is the only spot that has life. I think we'll find more. It's just a long ways away, but it behooves us to take the best possible care. Ladies and gentlemen, it is not just about the polar bears. It's about our children and our grandchildren, of which I have 3. That is Owen, Liam, and Josephine. When people ask me, why do you talk about climate change? Why do you bring it up on TV? That is the reason. My children and my grandchildren. What kind of a world are we going to leave behind? Not just for Keith Richards, but especially for them. Now, tonight, we have a very special program coming up, and it will be available on this same Facebook page starting at 7 o'clock with the Institute for Science and Policy, a project with the Denver Museum of Nature and Science. We're going to have an Earth Day at 50 special. Myself and 3 other very good speakers will be talking about climate change, the science, and the solutions. You can see more information on my Facebook page. You'll also be able to find it on the Denver Channel Facebook page as well. And I don't know, Kurt, if you're listening, and if you want to just dial in here and see if we have any questions while we're finishing up here, I'd be happy to take a few of them. So I'm going to just put my earpiece on here real quick and just see if we have anything that anybody wants to ask, or we can just move on from that point. I know it's been quite an afternoon. Hi, Kurt. Are you there? Yeah. All right. Okay. I think this summer in Colorado we're going to have a pretty active season coming up. It's going to get warm here in the next week or two. The question was, how's the summer outlook looking this year. And I think we're going to have a fairly active jet stream coming across, so probably a pretty busy summer along here as far as severe weather. I don't know if I'll be in my weather bunker the whole time or back down at the station for that. And folks, if you have other comments, questions, you can certainly go to my Mike Nelson Denver 7 Facebook page, or I can go back around to the very beginning here. Let's see, I can get back to where you get in touch with me. And let's see. See if I can bring it back up. I'll just leave this one up there. That's all right. Anyway, you can get a hold of me at Denver 7, and we can talk about it further. I'm very passionate about this subject. I have lots more information that is about there, ladies and gentlemen. If you have questions about feedback mechanisms or why this happened, or, hey, what about the medieval warm period or the little ice age, I can answer all those questions. Mike.Nelson@thedenverchannel.com, or go to my Facebook page. You can present the questions there as well. Kurt, do we have anything else out there? Right now, we're in between El Nino and La Nina. We're in a neutral pattern, so the sea surface temperatures are not unusually warm or cool at the present time. Ladies and gentlemen, thank you again for joining us on Weather Wednesday. Next week on Weather Wednesday, which hopefully will start at 2 o'clock, we're going to do the entire school talk live here in my basement with the radio songs and the hail juggling and the tornado dance. So be sure and tune in next Wednesday at 2 o'clock for Weather Wednesday. For now, I'm Mike Nelson from Denver 7. We'll see you tonight for our special Earth Day presentation right here on the Denver Channel Facebook page starting at 7 p.m. Thank you all very much.